Well, hello 3C. We're going to take a look at review of primary trig ratios today. And so our goal is I know how to find the sides and angles in right triangles using the primary trig ratios. Now we already did all of this in the previous spiral, but we're just going to recap. And I've got this nice graphic on here. It's up in the classroom as well. For reminding you what SOH stands for. And remember, sine equals opposite over hypotenuse. In between these letters is an understood division. Over, we're talking about ratios. Cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. And that's all written out for you down here as well. So we're just going to go through a couple of examples to find the missing sides and find the missing angles. So here's an example for finding the missing side, and this is an example where when we set up the ratio we're going to get a variable on top of our ratio. So let's take a look. Remember, when we do this, the first thing we're going to do is circle the angle that we're given, and then we're going to label the sides. So we have in this triangle, this is the opposite side because it's directly across the triangle from that angle that we're using. This is the adjacent side because it actually makes up part of the angle we're using, and the other side that makes up part of the angle we're using is the hypotenuse, and we know it's the hypotenuse because it's directly across the triangle from the right angle. So now we just have to figure out which ones we're going to use. Now this opposite side has no information on it at all. It's not asking us for it because it doesn't have a variable on it and it doesn't have a number, so it's completely useless to us. So we're looking for the one that has the A and the H in it. So if we take a look back up at SOH, we can see that the one that has the A and the H in it is the cosine. So we're going to set this up as cos equals adjacent over hypotenuse. And we're using the cos of 27. Remember, sine, cos, and tan don't mean anything unless they have an angle attached to them. Okay. The adjacent side is x, and the hypotenuse side is 20. So now we're just going to rearrange, and however you think about this, some people like to think about it as being cross multiplying, so we can understand this as being over 1, and if that's over 1 then we can cross multiply this way and then divide by this, which obviously doesn't do anything. So what we end up with is x equals 20 times the cos of 27 and then divided by 1. But I'm not even going to write that in because divide by 1 means absolutely nothing as far as the question is concerned. So now you just need to type that into your calculator, and we will get an answer. I just have to find my calculator. 20 times the cos of 27. Now remember, your calculator needs to be in degree mode. If you do not get this answer, 17.8, that means that you might be in a different mode in your calculator. So make sure it says D or DEG in the screen somewhere. Now this is a side, so we would normally put the units that are on here, but there are no units given to us on the side length of 20. So we're done, 17.8. Moving to the next question. We're going to find the missing side, and this time when we set it up, the variable is going to be on the bottom. So let's go through our process again. Here's the angle we're going to use. The side directly across from it is the opposite side. Across from the hypotenuse is, across from the right angle is the hypotenuse. And then the side that's left over here that is attached to this angle is the adjacent. Now this time we can see that the side that's useless to us is the hypotenuse. It has no variable on it, so they're not asking us to find it, and since it has no number we can't use it. So what we're going to use here is the O and the A. If you need to, you can write out TOA again so that you can look at it and see that the one that uses the O and the A is tan. This uses O, this uses A, but this uses both of them. So let's set this up. Tan equals opposite over adjacent. And then we're going to use tan with the angle of 40 degrees that we set it up with. The opposite side is 20 and the adjacent side is that x that we're trying to find. Now, this is, again, over 1, so we can think of this as cross multiplying if we would like to. But this time the cross goes the other direction. We have to multiply this way and then divide by this. So what we end up with is x equals 20 divided by the tan of 40. Whoops. Oh, I got a runaway pen here. Let's get rid of that. So divided by the tan of 40 degrees. And you're going to plug that into your calculator and we get 20 divided by the tan of 40 degrees, which is 23.8 approximately. And again, there is no units on here, so we don't have any units to fill in. Now the last thing that we're going to take a look at is how to use trigonometry to find the missing angle. And this will be the same for pretty much every angle that you're trying to find. Again, we're trying to find this angle in here. It's got a question mark. I'm going to actually change that question mark to a theta. Just makes it a little bit easier when we set it up. So this is the angle we're finding, which means that this side across the triangle is the opposite. Across from the right angle is the hypotenuse, and the one left over is the adjacent. Now when we set this up, we first notice that this side has no numbers, so it's completely useless to us. So we're going to use the O and the H. So again, looking at CAH, TOA, the O and the H is the sine ratio, so we're going to set that up as sine of theta equals opposite over hypotenuse. This time we're leaving that sine theta in there because that's what we're trying to find. The opposite is 39 and the hypotenuse is 44. Now to get the theta away from sine, some people say, oh, we'll divide by sine, but sine is not a number. Sine of an angle is a number, but sine by itself doesn't mean a number, so I can't just divide both sides by sine. And at this point, if you wanted to, you could get this as a decimal number. Maybe we'll do that right now. We're going to turn 39 over 44, 39 divided by 44, into 0.8864. 8864. Now notice I left 4 decimal places. I want you to do that too in the intermediate step. In your final answer you can round to 1 or no decimal places in the case of an angle. But when you're doing intermediate steps, you need to leave at least 4 decimal places. Trying to get the page to extend here. There we go. You need at least 4 decimal places just so that you don't get an early round off error. Now here's what you're going to put into your calculator, and I want you to write it down this way too. I'm not doing this just for my own benefit. This is the way I want to see you write stuff down. So theta equals sine to the negative 1, also called the inverse sine, of 0.8864. And when you plug that into your calculator, you get approximately, it says 62.4. I'm going to round it to just 62 degrees in my final answer. You can round sides to 1 decimal place. Round angles to 0 decimal places, or the closest whole number angle. Okay, so now you have some questions to do. Give them a try.